right, cool. So I guess we'll get started. So thank you all for coming to what is Babel and how do I use it. Let's see. My name is Logan Smyth. I'm a Babel contributor. I've been helping out with Babel for I'd say the last like 6 months or so. Got into it because we were starting to play around with ES6 and then got kind of totally involved. I mostly help out on the support channels for Babel and managing the issue queue and things like that, and submit patches when I get the chance. And that's kind of my main involvement at this point. And my full-time job is working on Inkling Habitat, which is a cloud publishing platform. So what is Babel? And it's a way to use ES6 today, right? So there have been tons of talks at this conference so far, if you've been paying any attention, really, about ES6. There was a talk yesterday on ES6. There's a talk right now on ES7. There was a talk earlier today, and there was another talk that was kind of like ES6 related yesterday, too. So it's a really hot topic right now. And Babel is, if you want to experiment with ES6 or try and use it in your code base, it's the way to do that. Assuming you're not working on a platform that has infinite support for everything, which pretty much nothing does at the moment. So what is Babel? It's a transpiler. That's kind of the standard term that gets thrown around for it. And what that kind of comes down to, it's not quite a real word, but it essentially comes down to a transpiler that converts from source code to source code. So a traditional compiler for like C or anything like that converts from C source code and outputs machine code. And that's fantastic, but it really doesn't work well in the web case. So what Babel does, and what many other things have started to do in the last few years, is take some other language or more advanced version of JavaScript and convert it into a version of JavaScript that actually works in past browsers. And that's what Babel does. There are tons of other examples. CoffeeScript is another great one where, again, CoffeeScript is a whole nother language that essentially gets converted into JavaScript. There's now also TypeScript, which is kind of an attempt to be ES6-like, but adds some extra features, has some other ones that aren't quite compatible, but otherwise, that's essentially it. And so Babel can take source code, output source code that will work on ES5 or any kind of older system. So where did Babel come from? Babel started about a year ago as a project by a guy named Sebastian McKenzie. He kind of started it as a project because he was interested in learning about compilers and everything, essentially. It was a totally fresh project. He's just a guy from Australia. He's pretty great. And so in the last year, because of kind of this drive to both standardize ES6, which is now finally standardized as of a few months ago, and this drive to just be able to use it today without having to, I guess, sacrifice support for older browsers, transpilers have become very popular. So you can see kind of the numbers here. Over the last essentially just 6 months, Babel has gone from kind of a project that some people used or might have heard of. It was actually originally called 6.5 because it was focused originally on ES6 to ES5, and now it's kind of grown to beyond that. So you can see this essentially ends up being almost 7.1 million downloads in the last 6 months-ish. And that's primarily on Babel version 5, which was released in April. There were kind of a few versions iterated really quickly at the beginning that kind of like were okay and worked pretty well, but things have kind of stabilized and adoption has increased a ton in the last kind of 6 months. So what are we doing here? I'm going to be running through a couple kind of examples to just cover the basics. I'm going to cover making a client-side server-side Node script, just dead simple. It's not actually a server, just Node script. I'm going to cover client-side use, so compiling code so that you can take ES6 code and use it in a browser, going back tons of browser versions, but it'll still work. And then I'm going to talk over using ES6 to develop NPM modules today, but writing them in such a way that they'll still work on Node 10, which doesn't support any real ES6 stuff. But before I jump into that too much, I just wanted to give a couple examples. If you aren't really familiar with ES6, this is kind of a quick example of what some input might look like and output. So I'm using standard kind of ES6 block scoping lets instead of vars. And this one ends up being pretty much a one-to-one conversion, right? So Babel is taking a variable called foo, and in the case of the inner one, it's inside of an if statement. So like the scope of it, of the inner foo, doesn't affect the one on the outside. And in the final output code, you can kind of see that behavior preserved, right? Because it's renamed the value on the inside, so conceptually they're two different variables. And that's kind of the basics of it. It's important to keep in mind that as things get more complicated and as you learn ES6, the features get a little bit more complicated to transpile, and they're definitely not just nice one-to-one conversions like this. But it's kind of a nice example. So right, you can see here, the foo on the inside, console.log is going to print baz and then bar kind of nicely, and the code will just work. As a more complicated example, here's an ES6 class. I've actually trimmed down the output a little bit just for readability's sake, but you can see there are two new functions that are in there that it's calling other like helpers for like creating a class and verifying that a class is called with new, because that's a requirement for ES6. So this is a solid example where functionally it'll behave pretty much identically to the equivalent ES6 code, but it's a lot more complicated. So kind of jumping into Babel itself, here's essentially the like dumbed down version of how you use it, right? You'd install Babel, and then you have kind of two different options for compiling it. Babel on its own has a bunch of different packages on NPM. The default one that if you're just like playing around with it, the easiest way to play around with it would be to install the Babel package. That essentially allows you to have some command line scripts to take a file and compile it. So here's two simple examples of taking a directory that's called source and compiling everything in it and putting them into a directory called lib, or compiling one individual JavaScript file and putting it into an output file. And that's kind of the core of what Babel does file-wise. And so something that I wanted to kind of talk about briefly, because it's a sticking point that a lot of people kind of conceptually have, or I guess trip over when they're first starting. So Babel, specifically on its own, when you're using it in a case like this, has one specific goal, and that's to take ES6 syntax and convert it into ES5 kind of equivalent code that'll still work. And that kind of sounds simple on its, like, in the face of it, but one important case there that isn't necessarily obvious is that there's a lot more to ES6 than just ES6 syntax, and that's there are new library functions. Every new object has, there's now string includes and array.from and tons of stuff to work with kind of everything that's new, and there's new symbols, right? That's a brand new thing in ES6. So support for that kind of thing is not, it's not provided directly by this. And so that's something that you have to think about as you're going into working in your application. And that's provided by general polyfills, which is something that you're probably all familiar with in one way or another, right? There's tons of APIs that are kind of standard on the web these days that maybe they don't work in older browsers. And so you load a polyfill from, maybe you're loading a polyfill for something like class list or something like that on a node. Or anything really. So Babel has the same thing, or if you're developing an ES6, essentially you need the same thing. And it's up to you to make sure that something like that gets loaded. So when I go over some examples, I'll show how you do that. But it's something that I wanted to talk about up front because it's important to think about when you're approaching things. So let's try and jump into some examples here. And I will not break my neck too much looking around here. So this is kind of a basic example that I put together. This is the client-side example first. So let's jump right into it. Let me make this a little bigger for y'all. So I've got just a really simple Node module. I have a package.json directory with source that has everything. Oh, and also just let me go back one for a second here. This code is all going to be available on this repo if you want to look at it right now or if you want to look at it afterwards. So I see lots of people taking photos, so I just want to call that out right now. OK, so client-side example. So first off, since we're doing client-side, I'm going with Browserify, which you may or may not be familiar with, but it's essentially a really easy way to take a bunch of JavaScript files written kind of in a Node style and bundle them up so they work in a browser. And Browserify has the ability to basically register functions that will get called on every file that it processes. So in the case of Babel, the main thing that you have to do is, well, install Browserify, install everything. So here I've got Browserify. The main thing after that is installing Babelify, which is a plugin for Browserify. Browserify has this pattern where essentially every plugin ends with ify, which is kind of confusing at the beginning. So you have in your package.json this, and that says any file that Browserify in this repository processes will get processed by this plugin ahead of time. So Browserify will load that and process it. So now it kind of comes down to Browserify. So I have kind of a simple example that's a little bit longer than I was hoping. There we go. So this line here, I'm telling Browserify to compile my index file from this application and package it into a distribution kind of bundle.js file. So let's see, yeah. So I actually have that running here. I have a little web server running up here too to actually serve this up. So if we actually look at this, we've got here we go. One script that just has that bundle.js file, and you can see that it is sticking some text in there. So let's go look at that actual index, right? So we're compiling index.js here. So this is my index, and it's written in ES6. So I wanted to show off kind of the basics. I'm not going to go into ES6 in depth here. There are tons of talks that have already kind of covered that. But this is ES6 import module syntax. So I have two files, index.js and messages. And this is pretty much exactly what you can see here. So grabbing a string from another module, and then I'm sticking it in the body. And that's kind of the core of it. That messages file is, again, ES6, and writing it and just exporting that string. So let's jump back here a little bit. I mentioned polyfills before. This particular example is pretty straightforward, so it doesn't realistically actually do anything that needs polyfills yet. But as soon as you get kind of anywhere complex with ES6, you'll either want a polyfill or to make sure that you're running in an environment where you're absolutely sure that it has everything you need. So here, Browserify has this nice feature where you can just pass it an array of files. So I'm just passing the polyfill here. So Babel exposes a polyfill file at the root of all its repositories to just make your life as easy as possible. The type of polyfill that you load is totally optional. You might be running in an environment that already has everything you need. If you're running on Node 4, maybe you don't care that you have to load a polyfill. And this loads a polyfill called core.js. So Babel doesn't actually provide anything. This just calls through to another dependency module afterwards. And so that kind of gives you the flexibility to load pretty much whatever you want. But this will make pretty much all the standard ES6 functionality work the way you would expect it to. All the globals will be there and all that. So if you're not familiar with NPM scripts, I can chat about that quickly. NPM basically exposes a way to run commands really easily, kind of per repository. So when you're first starting out, using them is pretty easy. You don't have to have extra build systems. You don't have to play with gulp or anything like that. As your builds get more complicated, you may very well want to do that, but these examples kind of tried to be as straightforward as possible. So I'm relying on NPM scripts here. And basically, I've exposed 4 different commands that I can run. And they kind of have different intentions, right? So build probably would be like what you'd run if you're going to take this file, build it, and then deploy it to a production site. If you're doing local development, I have a watch. And that essentially means that if I run that, NPM scripts, basically you do npm run watch. And it will basically run this command right here for me. But the key part is that I don't actually have any of these commands in my path. They're part of this module, and npm will automatically make those available when you're actually running your npm scripts. Otherwise, you have to set up your terminal path or manually specify it, which is kind of a pain. So npm scripts kind of solve all that for you. If you saw in my previous example here, the alternative, if you were actually running it in the terminal, is to do something like this, where you ask like npm, where do you put all your binary files, and then run the command in that location. But it's kind of a pain to have to type that all the time. So if you can actually rely on npm to just run it and know where that stuff is for you, it can be a lot easier. So now this watcher is running. For instance, if I make a change here, then that should recompile for me. I don't actually know if Browserify prints anything when it edits, so let's just see what happens. So if I edit that and then refresh, bam, there it is. So this watch script updated the bundle for us, and now pretty much just works. The other piece here that I tried to make all these example modules cover like the basis of what you'd probably be interested in. So I also included tests. Because this is client-side, I'm actually running the tests in the browser using what's called Karma, which is a test runner that like automatically opens browsers for you. So if I do test in this case, it's going to open Chrome for me. Oh, and give me a warning. I was probably supposed to, let's see. Oh yeah, so obviously because I just edited that text, the test failed. So if I go undo that change that I made, run those tests again, it'll open it up, and bam, success, 1, 1. I'm going to hit allow so that doesn't happen again. So that's the core of essentially using Babel for client-side. Browserify is not your only option. There are tons of other ones, Webpack probably being the most well-known competitor for Browserify. But it's basically, again, a system to take standard Node modules, bundle them up, and make them work client-side. And both kind of expose this mechanism for processing individual files as they're bundled up, which is perfect for something like Babel. Babel processes like each individual file one at a time. And it doesn't really have to know anything about the individual pieces. So I think that's the core of this. Watching is super important. So if you're developing a workflow, I would definitely make sure that you have that in there. In a simple example like this, realistically, you could rerun build every time if you wanted to. That's mostly a pain when you have small stuff like this, but once your application gets to a certain size, watching is pretty critical, because building like every single time running just a straight up build means that it has to redo a ton of work for every single file, even though you might have only changed one little thing. And so watch will only reprocess the things that matter, essentially, or the things that have changed. So let's see. Yeah, so there are a ton of other things that I installed to make the tests and things work, but the core of it, again, is I installed Browserify, I installed Babelify, and then I told Browserify to use that on any file that it loads from inside this repository. So moving on to, I guess, our other examples. So let's see. Cool. So this is just a basic Node script. It's pretty straightforward. doesn't really do much. I already talked about package.json. I'll come back and go over the details. But this is another one that is just, I decided not to approach it as like a server. So this is just a straightforward, if you wanted to write a script in Node in ES6, and you like had to support an old version of Node or something that didn't support anything for ES6 yet. So this just reads data that I imported from this other file, and then prints out the result as JSON. So before I go into it, I'm just going to run it. So if I build that up quickly, I run this, prints out my JSON, pretty much the way you would expect. It's just sourced out of a CSV file. So I pretty much kept these all consistent. So again, here we have a build, a watch, and a test commands. In this case, instead of using browserify, I'm just using the Babel CLI scripts directly. Again, that's just a really simple command script that takes directory and an output directory. So when you're doing production builds, you probably don't care too much about debug information. You just want to take everything from source, compile into lib. If you're doing local development, you probably want to enable source maps. So I have enabled that here. Source maps are kind of tricky. If you're working in Node, Node on its own doesn't support source maps. You have to actually install an NPM module and then run it at this kind of the entry point of your application, and that will it overwrites a bunch of the globals in V8 so that it can reach in whenever there's an error and process the stack traces. So there are kind of a bunch of different ways that you can do that. I didn't go into that for the standard case, but if you're using this fancy thing here that I'm going to talk about now, some of that gets done for you automatically. So let's just run that quickly. So for the test case, here my test kind of just ran. And I have this thing here called Babel register. If you're running in Node, Babel exposes a helper that basically, kind of the same way that you might have used CoffeeScript or something like that, where just requiring a CoffeeScript file in development will automatically compile the CoffeeScript file into JS for you. Babel has something similar to that called register. And if you run the register function, then it essentially changes the behavior of nodes, the way that Node loads JavaScript files. So that means that anytime you load a JavaScript file after that, it will automatically compile it from ES6 to ES5 for you. The other thing about register is that it automatically adds a polyfill for you. So if you're writing a Node app, chances are you just want to load a polyfill and not worry about it. Polyfills, generally from a performance standpoint, they're good enough that you can just load it and not worry about it. And for the client-side example, again, once you get to a point where you're really caring about file size, you can revisit that, but I wouldn't worry about it yet, because there's lots of better things you can be spending your time on when you're first starting. OK, so talked about build and watch. I showed that that's working. I want to just mention quickly here. So essentially for Mocha, what this is doing is it just requires that file ahead of time. This file is something that if you were writing your own app and you wanted to do this from scratch, you could just do require Babel register at the top of your file, and then any file you require after the one where you run that would automatically get transpiled for you. And if you're writing in Node, especially if you just want to iterate quickly, stuff like this is great because it means that if you're running your tests, you don't even need to be running your watcher because the test command will automatically transpile it as it's loading the tests. And that can be super nice because if you're doing, maybe especially if you're the type of person to do test-driven development or something like that, having to run a watcher separately and then run the tests can be a pain. So this is pretty nice. So like you saw here, again, this will automatically compile it for you. And you can also see that because we're not using browserify or any browser tests, the dependencies for the Node example are way shorter than the other one. So a straight up Node example is really easy. The other thing I'm going to mention because it's useful, but also has a bunch of edge cases, is there's another alternative to Babel register, especially if you're just playing around. And that is, along with the Babel CLI command here, Babel also exposes something called Babel node, which basically works exactly like the main node executable, except that it automatically does register ahead of time. So if you have a file written in ES6 and you just want to run it, then you can use Babel node instead. So instead of doing, node index.js, you do .index instead, and that would like automatically transpile it for you. Generally, we don't recommend using that in production for kind of a bunch of different reasons. One is that, again, if you're doing it in production, that means that you're going to be potentially transpiling every time you deploy, or every time you have to restart your application. And one of the huge benefits of Node to begin with is that it restarts really fast, so having to then block the start of your application on transpiling ahead of time is probably not a great idea in production. But if you're testing locally and you just have a file you want to run, go for it. It's great. So that's kind of the core of this. Let me see. Yeah, so the other part that I wanted to mention here, and I have one of these in the other repository too, but it didn't really go into it there, is Babel has a ton of options, right? So far here, I have been using Babel in like its totally default configuration. And that's great if you just want to use it. That means the default is that pretty much it'll compile something that works everywhere. There are a couple downsides to its default configuration. It doesn't really do anything, it doesn't have any smarts. So it has exactly what its defaults are. And so that means, let's see, if you're running in Node 4 or Node 12 even, and you have generators available, and you don't want to automatically transpile generators into an ES5 version because you have native support for it or something like that, you can tell Babel to disable certain transformations that it does. And the way that Babel is kind of designed is that it has this giant list of transformations that it performs on the JavaScript that it gets as input and then converts and then outputs. Here I'm running Node 4, so that's great. I could use generators. I don't actually have any in this repo, but I'm going to just demo. So Babel has a couple different ways to configure it. The easiest way is you can create a .babelrc file in your, I guess it doesn't exactly have to be in the root of the repository, but any file that you process with Babel, Babel will look for the nearest babelrc file, the same way that it might work with ESLintRC or JSIntRC, any kind of standard RC file, and it'll look for options in there. I guess one thing I have in here is stage 4. If you were here for the talk before this, there are kind of a bunch of different stages of proposals for JavaScript functionality, whether that be library functions or syntax. By default, Babel enables everything that's stage 2 or greater, which means that potentially you can get a ton of stuff that is pretty well proposed and probably pretty stable, but it's not actually in ES6 yet. So I would recommend probably to set the stage to 4 if you're just working in Node and you don't want to, especially if you have a big code base or a bunch of developers working on something, you don't necessarily want to risk someone accidentally using something that isn't actually officially ES6 yet, or maybe it is, but you should be aware that you can make that choice and probably should when you're starting out. So to go back to my generator example, one of the options for Babel is that you can blacklist certain sets of transformations, and that's make that valid JSON. Not sure if that's actually required, but so you can blacklist certain sets of transformations. So I mentioned that Babel has a ton of different transformations, and they're all documented on the Babel website. You don't necessarily have to go through them all, but here they are. You can see standard ES6, and there's a few to support older ES3 stuff. If you had to compile for older IE support, things like that, you probably want to make sure. These, again, they're enabled by default, but you should know they're there. And then there's all this experimental stuff. And a lot of this is that stage 2 and lower things that are cool, but you may or may not actually want to use. And there's other stuff, right? So we have one for working with React. Some of that's enabled by default. So that's like if you're working with React, chances are you want to use JSX. Babel supports JSX automatically by default. And then it also supports like Flow, which is another Facebook thing, among others. There's like, if you have really old IE, you can enable certain things for IE support, stuff like that. And then there are a bunch more that I'm not going to go over, but they're all there if you want to look at them. So you can blacklist certain things. If you wanted to just use generators normally, you can add something like this into your application, and it will disable regenerator, which is the library that converts generators into ES5. So I think that's the core of the Node example that I wanted to run through. And the last one is basically writing a Node module, but with kind of a few limitations. So if you want to write a module that you're going to take, actually deploy publicly, or maybe you want to submit it as a public NPM module because it's cool functionality that you want to share with the community. Maybe you already wrote it in ES6, maybe you just want to use ES6. That's awesome, but there are a few kind of edge cases that you have to think about. And the main thing is that it kind of comes down to polyfills, which is what I mentioned before. If you write a module that you want to publish on NPM, you don't want to have to make assumptions about polyfills. Like if you're using a function, you want to know that it's going to be there, essentially. So, I mean, there are a couple ways you could do that. You could assume that the people using your library have loaded a polyfill. That's kind of gross. You can actually have your library load a polyfill, but then anyone who uses your library is automatically going to be polyfilling everything about ES6, even though they have no interest in doing that and don't care about the internal implementation of your module. And the third option is another option in that Babel config file, and that's runtime. Which if you're writing something that you're going to distribute, you'll probably want that in there. There are a few edge cases to this that you'll have to be aware of, but go for it. So the main thing with runtime is that it will go through and look for references to things that are ES6 related and that are like globals, essentially, that it would normally have been there if you had loaded a polyfill. And it will actually rewrite those to reference, like, actually be a require statement that points at a polyfill. And that means that you're not actually using globals, even though as you're writing your code, you're writing with globals and you don't have to really think about it too much. So if we look at the index for this, I'm using promises, right? So if I actually run these tests, for instance, they passed. That's cool. But if I want to do the same thing on Node 10, Node 10 doesn't actually support promises, right? They're not natively installed, but I'm running this code and it's actually working, right? And in this case, it works because of that runtime option. So by loading that, it's basically going to come in here and look for promise, and then it's going to put a require statement in there to load promises from a polyfill for you. The one downside that's critical to be aware of for runtime, or let's see, there's two that I'll list. One is that because of the way that runtime, I guess the goal of runtime, it's not to have globals, right? That means that you can take your code and use it anywhere and not worry about polluting anything. There are unfortunately stuff in ES6 that pretty much require globals to actually have work. And so those things don't work the way that they're standardized to work. So it's kind of, I guess here, I can show an example. So like, even if you just had this, to something. So if you wanted to use includes, right, that includes function lives on string.prototype. And there's really no way to intercept that ahead of time. So if you're using runtime and you're using a module or writing a module that's going to be distributed, you'll have to avoid prototype functions like this because they will not be there because it's impossible to catch that ahead of time. So you can use promise, you can use, ray.from, you can use symbol, and there's tons of new stuff in ES6. So you can use all this, and more importantly, any code that Babel generates can also use that stuff, right? So if you use, a for of loop or something like that, Babel's going to be using symbols in the background there to actually make that work, because symbols are required for iterables. And so having runtime means that that'll all work the way you expect. So again, I have the runtime in there, and then just to go back to this to show it, it's pretty much the same as what we had in the actual Node script example, right? We're using Babel, compiling, watching. The other thing here is just, again, if you are writing an NPM module, you want one of these, and that just means that when you tell NPM to publish your module, it will run the build script for you right before it publishes it and packages everything up for you, so that the code that actually ends up in your NPM repository or tar file or whatever it ends up being in NPM will have that lib folder in it. Because otherwise, you don't want to drop into your repository and run publish and then have forgotten to run build or something like that, because then you've deployed a version of your module that doesn't actually work and is totally broken. Or even worse, is like still using an older version of the code. And let's see. So that's the core of it. Oh yeah, I wanted to jump back and mention one other thing about runtime, because I said there were 2 limitations, and I only answered one of them. Is runtime, at this point, still has a few issues on older versions of IE. So if you have to support older versions of IE, things get difficult. And then you have to make some of the hard choices that I talked about polyfills and whether you assume that things are global or not. And that's because some of the things that are required to actually make ES6 stuff spec compatible doesn't actually work in like IE 10 and below. So if you need to support those browsers, then things get a little bit more hairy, essentially. Yeah. Right. And then, right, the only other thing about runtime is that you need to have runtime actually installed, because it puts all those require statements in there, and it's going to put require statements in there for this module. And that means that if you're deploying this, anyone who uses your module doesn't have to install all of Babel just to actually use the polyfill, essentially, which also helps make your module smaller and more straightforward. So I think that's most of it. Let's see. Cool. So what is Babel, right? So that's why we're here. I've gone over a ton of examples on how to use it. There are just a few more points I wanted to make. There's a lot more to Babel than just it being a transpiler. And as you get used to it more and like it's more integrated into your workflow, there's some more advanced stuff that you'll probably you either want to explore or consider or just know is there. So Babel really is a framework, right? I mentioned all these transforms that run on the JavaScript code as you're essentially using it. And most of those are split off into actual independent chunks that can be toggled on and off. And the way that works is by actually Babel having a public API that you can use to write all these transformations. So almost all of the transformations that Babel does are standard plugins. So if you had code that you wanted to write yourself or something in your application, maybe you're writing a DSL or something like that that's actually embedded into your files. Or maybe you just want to do something simple like in production builds, make sure that all the console log statements are deleted or make sure all the debugger statements are deleted. Those are 2 plugins that are actually available through Babel, but they're good examples of like really simple things that you might just want in your production workflow, right? So all of this is totally standard. And so Babel's APIs work on top of ASTs, which are abstract syntax trees. There was a whole talk about them yesterday. I'm not going to go into any details. But basically, it comes down to what you see on the right is what Babel actually sees, right? So it's the equivalent of the var statement over there converted into a huge pile of JSON. And Babel will take that, process it, and then put it back out again. And so you could write any scripts you want to actually work with that and do those types of transformations too. And that includes changing things, but it also might include going through and like you can ask Babel, oh, what variables are available to me, or what variables have been declared at this point, or insert a new variable for me here and make sure that the name doesn't override or conflict with stuff that's already in my code, things like that. And at the end, that whole framework system comes out as being a full ecosystem, right? So at the moment, I mentioned the Babel package. I actually haven't mentioned Babel core, but Babel core is essentially most of what is Babel. The Babel package on its own on NPM is command line scripts, and then everything else is offloaded to Babel core. That is kind of the Uber repository at the moment that has almost everything in it. The only thing at the moment that's split off is the actual parser, which is called Babylon. A lot of what I'm said, unfortunately, is going to change in ES6, or at least in Babel 6. Right now we're on version 5. Version 6 is going to be coming out relatively shortly. So like I said, my slides are on GitHub. I'm going to try and go through and update those once Babel 6 gets released so that they're actually still usable. But a lot of what is in Babel core right now, including the transformations and everything, is going to get split out into separate repositories and separate NPM packages to make them a little bit easier to compose and use together. Join us. Babel has kind of, I would say, the primary community for chatting about ES6 and answering questions is on Slack. So a lot of us here probably already use Slack. We have just an organization that you're welcome to join. Our main chat room just has a bunch of people that hang out and chat about Babel and ES6 and stuff. Or ask questions on Stack Overflow. There are also a bunch of people that are more than willing to help there. And if you find bugs, please file them on GitHub. We don't love hearing about bugs, but obviously there are some, so make sure to let us know. We try to avoid having questions on GitHub because it tends to clutter things up a little bit, so if you have questions, definitely go with the first two options. Yeah, so thank you very much. The slides, again, are on GitHub along with the sample code that I talked about today. So thanks.